Well, hello there. This is Craig Hain, and this is going to be chapter 10 of the book, How and Why Homeschool Math Can Be Vastly Superior to Public School Math. And I'm Craig Hain, the CEO of Triad Math Inc., and the creator of this book and the program that we talk about in it. And this is chapter 10, and I'm guessing this may be the most controversial chapter in the book, probably, certainly from people that are involved with public high school education, because the title is Why Public High School Math is Failing Our Students. Now, let me start with a couple of questions. What happens if a student gets discouraged with math early in his or her middle or high school career? Gets really discouraged. And what happens if the student decides that he or she just can't understand math and is not going to be able to pass these required tests to graduate from high school? Well, some students carry on even though they're discouraged, but a lot of them give up. How many students give up and drop out of high school because of math? Now, there's lots of reasons students drop out of high school. I realize math is just one reason, but if you're discouraged by something, you say, hey, I can't do it. I'm not going to be able, I don't like it, I hate it, I can't do it. What are you going to do? Well, there's a good chance you're going to give up and drop out. Well, if that happens, and if that's the reason the student dropped out, the question is, what does it cost a student in terms of his or her future job opportunities in her life? What's the cost to the student? And my answer is, for many, many students, it's pretty disastrous. They end up joining gangs or doing something that menial, and they just don't have very good lives. And what does it cost to school? After all, schools are funded by students. I know a lot of schools that lose a lot of funding because of dropouts. Now, I'm not saying it's all caused by math, but I suspect that's a big component of it. I don't think they have statistics on it, frankly. What's it cost the community and the school in terms of funding? Because schools get a lot of their funding from the states. Well, what does it cost our economy to have a student that's not going to be very productive in the workforce and is maybe going to be a real drag on our economy in many ways? And maybe not because of the student's fault. After all, they're the victim of it. What effect does that have on our society? Now, I can't answer these questions, but I think by and large it's very, very negative. And I believe that it's a horrible situation. And I think that's especially true considering that it is so unnecessary to happen today, as this book is all about. Okay, now another question is, what happens to a student that's interested in some STEM subject? Maybe he wants to go to college and study science or engineering, but they just can't learn the math. They can't learn the necessary concepts and tools they need in order to compete with better trained students. A lot of our international students today have much better training than our USA students. Just go ask anybody that's teaching university at the graduate level in STEM or even the undergraduate level. Will you tell me what these consequences are? Personally, I think the consequences are horrible for the individual student that is discouraged from STEM because of math. I think it's horrible for our economy, our society, and really our future. And again, this is so unnecessary today. So let's think about the effect that our current standard math curriculum is having on our public high schools. I talked about the standard math curriculum in chapter 9. Talk about it more here. Well, there's three categories of students as I see it. First of all, there's a category of students that are not going to go to college. But what they need is they need what I call workforce math, what we cover in tiers 1 and 2. And that will empower them to pursue a wide variety of career paths in the technical world we live in today. Now, this math, this workforce math, if I call it, can be taught to them very, very easily in 1 or 2 years if the proper content is taught and if the spike pedagogy is utilized. And I talk all about that in other chapters in this book, so you need to fully understand that. But if that happens, it's going to be great for them. Now, these are the students that can get discouraged and drop out of school if they get too discouraged with the math that's taught in the standard math curriculum, because our standard math curriculum doesn't do what I just said. And of course, it's a huge loss and cost to our economy and our society, and needless to say, a disaster for the student. And as I said, it's so unnecessary. thanks to modern technologies. Just look at our earlier chapters on that. I think chapter 2 we discussed that. Now, there's students that plan to go to college, but they're not really interested in science or engineering. But they need really the same workforce math and the consumer math that the other students need. That's going to help them. Well, they're also going to need some extra math to excel on the exam like the SAT and the ACT so they can get into college. But I'll tell you right now, that's not very much additional math. In fact, go see our Tier 3 syllabus to see what they need. They also need coaching, of course, on how to take a timed, tricky exam, which those exams are. Well, once again, our standard math curriculum is not an easy way for them to get what they need because there's so much more in it than what they need just for these tests. The standard math curriculum, if two people can survive it, get on it, are really basically for STEM students. So most of these students now in this category do survive our current standard math curriculum. It's unpleasant for them. It's pretty costly to our schools and our society, but they survive it. So it's not a total disaster, but it's not good. Now, here's the real problem I see today in our country. Students that wish to study STEM subjects. This is where our current standard math curriculum is most deficient. Now, I explain that in great detail in chapter 6. But you need to understand that the STEM math situation, if you're going to fully understand the situation, and I consider this a huge tragedy today in the United States. This is why our students are such a disadvantage when they start competing with students who have been properly trained with our modern technologies that I talk about in the STEM math. Now, this is one reason why, a big reason why, I believe that homeschool math can be vastly superior to public school math. We can teach our STEM students what they need to know. Now, this is going to be, I'm sure, a controversial statement, but I think anyone that really understands STEM math requirements is going to be obvious. And just think about the consequences to our economy and our society if we were training our students, because this is going to be the future of our world, is science and engineering and all the technologies that are developed from it. And this is where, if a student is trained into this, they're going to have a wonderful career. They're going to make good money. They're going to have great. It's just going to be great in many ways. And if they can't do it, they're going to have to do other things that may not be as well for them. So I think we owe it to any student that wants to try to study science and engineering to give them the kind of training I'm talking about, the modern training. Okay, now let's just say that you've not read all the previous chapters and you're just reading chapter 10. So I'm going to give you a quick synopsis of the situation. If you have read all the other chapters, you might want to stop now and go on to other things. The problem is, as I said earlier in other chapters, the standard math curriculum is what I consider the culprit. Now, the first problem is it's way too compartmentalized. In our modern standard math curriculum, and this goes back now over 100 years, we divide math into subject areas. And we call them various pre-calculus math, we call them. We have pre-algebra, algebra, college algebra, plane geometry, solid geometry, trigonometry, analytic geometry, and so on and so forth. Now, this division into these individual subjects has got its roots really in the early 19th century, the early 20th century math curricula, and all goes all the way back into the 19th century. And quite frankly, it has not advanced very much in a positive way in the 60 years that I've been involved with mathematics. First as a student, and I consider myself a victim actually then, but I survived it, thank God, a couple of teachers. Then I was a teacher. I've taught high school math as a tutor and as a teacher for many, many years, and of course as a mathematician. In fact, I consider that our math curriculum is a product of what I would call evolution and not a product of what I would call intelligent design. Now, I'll tell you what that means in a moment. I'm not talking about biology now. I'm talking about our math curriculum. There is an analogy there, though, isn't there? Okay. The student today in our standard math curriculum is left with the impression that these various subjects are somehow independent. It's a horrible misconception. Unfortunately, shared by some teachers. Why? Well, they're forced to specialize. Well, this teacher teaches algebra. This other teacher teaches geometry. Another teaches trigonometry. And they treat them as separate subjects when they're really not. They're very, very integrated. All these subjects, algebra, geometry, trigonometry, and so on, are intimately related, and they're interconnected. And any good mathematician will tell you that. It's very difficult to solve modern practical problems without using the concepts and the techniques from several of these areas all together at the same time. And the sooner a student realizes this, the better off they're going to be. The sooner they get a basic mastery of several of these topics together, the better they're going to be. So I think a student needs a foundation as early as possible. And that's, of course, what we do. In less than a year, no more than a year, a student can get a foundation in algebra, geometry, trigonometry, the scientific calculator, and all of that. I call that workforce math in other places. Now let me give you a quick example that I've done in other chapters. Here's a problem for you. Find the area to 2 decimal places of a triangle whose 3 sides measure 3 feet, 4 feet, and 6 feet. Now the answer is 5.33 square feet. Now I'm going to tell you now, this is a kind of problem that could arise in a practical situation. And you say, well, that's pretty easy, area of a triangle. Well, it looks easy, but it's not easy unless you're properly trained and can use a scientific calculator. I do all that in Tier 2. If you don't think so, try to solve that problem. This is not a right triangle, and that's why it's so difficult. You can't use the formula 1/2 base times height. The usual formula that geometry teaches, 1/2 base times height, doesn't work. Now, you can solve it with algebra and geometry using what are called simultaneous quadratic equations. Almost nobody ever teaches that or knows that. It's very hard to do, very tedious and difficult. If you happen to know something called Heron's formula, by the way, that's in George Simmons' book, you could use it, but nobody knows that. Nobody uses that. A very good solution is to use some trigonometry and a scientific calculator. And then you can solve it in less than a minute. And that's what you'll learn that in Tiers 1 and 2, what I call the Practical Math Foundation, or basic, it's workforce math. It's very easy to find the area of any triangle if you're given the 3 sides. Here's another example. So you can just look at it and try to do it. Now, in the standard math curriculum, this problem would not be presented in a geometry class. The problems there are rigged to be solved with a very limited manual tools there. If you give this problem to any high school math graduate, or even teacher, see how long it takes them to do it. See if they don't just give up on it. Now, this is just an example of a practical problem. And it could require, you might have to take math for 3 years in a high school standard math curriculum to get this. And there's many examples like this. I just give you this as one good example. There's all kinds of examples like this. Now, I consider this simply unacceptable when you consider how unnecessary it is. It's very, very unfair to the students. Now, in a modern curriculum that's intelligently designed, these various subjects can be taught together in a tiered or layered manner so the student can realize these interconnections very early on, say within 3 months. In fact, in Tiers 1 and 2 in our program, the basic facts and techniques from algebra and geometry and trigonometry are all presented, integrated together, so the student can see these interconnections, usually in less than a semester, no more than a year, even for slow students. And they can solve many practical problems, just as an example I just gave you. Many, many more. That's just one example. There's many examples like that. The students can't solve after, say, the freshman year of algebra. All kinds of problems they can't. They're nowhere near ready for the workforce. You can take algebra in the standard math curriculum. You're not ready for the workforce at all. And by the way, you will learn all sorts of stuff you'll never use. You'll have learned theoretical things that you'll never use, like irrational numbers. You'll learn all sorts of algebraic manual techniques that are obsolete now, thanks to modern tools like Wolfram Alpha. So that's just the way it is today, and that's why our standard math curriculum is so horrible, and it's killing our students. Well, that's a strong term. It's grandly harming our students and our teachers and our schools. You got to introduce modern tools early. We're in the 21st century, for crying out loud. If you're going to drill a hole, use an electric drill. Don't use a brace and bit or a hammer and a nail. Use a modern tool. Now, if you do that, these concepts are very easy to understand, much easier than they're being taught today. The concepts of math for algebra and trigonometry and calculus are really easy to learn, the concepts. It's the tools that are hard. You need to introduce a scientific calculator very early on. I introduce it to my children very, very young. And you can use it then to help them learn the concepts and eliminates the need for the obsolete manual algorithms. When's the last time, if I give you 2 big numbers to multiply together, are you going to use pencil and paper or are you going to use a calculator? Tell me. What are you going to do? What if I ask you to take the square root of a number? There's a manual algorithm. Are you going to use it? Are you going to use a calculator? Or are you going to go back and use a slide rule and logarithms? I don't think so. You're going to use a calculator. Now, That's something anybody can understand. You know calculators are valuable. They've been around for 40 years, and you know the calculators are absolutely critical when you do arithmetic. Well, now what about modern math? What about analytical geometry and trigonometry and calculus, which you need for STEM? Well, Wolfram Alpha does for that what the calculator did for arithmetic. It's a 21st century tool. It was introduced to the world in 2009. It's an amazing tool. This, in my opinion, is the critical deficiency of the standard math curriculum. Pardon my spelling. I see I misspelled a word there. Well, you make mistakes, don't you? And no big deal. Okay. Now, what we have to do today is create an entire whole new math curriculum. You can't just take the current one and edit a little bit and tweak it a little bit and change it a little bit. That just creates more books. That's what they've been doing for 100 years. They just get the books get bigger and bigger, more expensive, fancier pictures and all that, but just loaded with obsolete and irrelevant stuff. We need a whole new math curriculum. And that's, by the way, what I've done in tiers 1, 2, 3, 4, and 5, and 6. And you can look at them. Now you might say, well, why hasn't the math ed community done it? Why haven't they done it? You tell me. Why haven't they done it? You tell me. Well, could it be that they have a huge investment in the standard math curriculum? They've been evolving it for over 100 years. What about all the books they've written, these big, thick books that are expensive? Guess what? They're as obsolete as a slide rule is. It was a great trauma for the math ed community back in the early 1970s when the scientific calculator came out. All the books with slide rules and log tables and trig tables were obsolete. Oh my goodness. Well, that's happening today with Wolfram Alpha. And by the way, other countries understand this. You want to compete with an international country, they know this. They don't care about selling the American expensive books. What about having online teachers? You can have an online teacher today that's a great teacher for almost nothing. In fact, if you go to Khan Academy, there's free YouTube videos on all sorts of math subjects. In fact, if you're studying the standard math curriculum and you want help on some of the topics, go to Khan Academy. He has great videos on the standard math curriculum. I don't use them because I don't teach the standard math curriculum. It's the wrong thing, but that's what he's got. But you do need coaches at local level. You got to have coaches. Now I have a whole chapter on coaches, teachers and coaches. You got to understand there's a difference between a teacher and a coach. Might be in one person, but usually it's not. And you got to have at the personal local level coaches. Well, you got to revolutionize these standard math tests that we're using today. This SAT and the ACT and these tests are horrible. Why? One test for everybody. You need to take into account the needs and the goals of the three distinct categories I mentioned above. If you're going into the workforce, believe me, you don't need what's on the SAT and the ACT. But they don't test you for what you do need. If you're going to college and you're not going to study STEM, there's all kinds of math that you don't need that's on the SAT and the ACT. You just don't need it. But yet they make you learn it. Now, if you are going to study STEM, you need things beyond what's on the SAT. My goodness, you can score 100% on the SAT, and you're not ready for MIT. You're not ready for STEM math. There's all sorts of things you don't know. These standard math tests today are horrible at every level. I can't think of any justification for them in any sense of the word. I consider them a grand hoax. I consider them horrible for our students. They're horrible for our teachers. My golly, they're making our teachers teach to these horrible tests. I mean, this Core 40 curriculum is just an abomination. Well, I'm hoping that the homeschool tribe, I call it that, community, can lead the way by demonstrating just how successful a 21st century approach can be compared to this obsolete and horribly expensive and ineffective standard math curriculum. That's what I'm hoping. And by the way, if you're a parent and your student's going to a public school, you can still homeschool them with math. You can still do that. I did that with my children very successfully. And they've been extremely successful in their lives because I was able to give them, they went to public schools, by the way. My children, all three did. But I gave them extra training at home on what they needed. And it made a tremendous difference. And I don't want to brag about them, but they've done great in their lives. So I'm going to sign off with this particular video for this chapter 10, and I'm just going to say supra. What does that mean? It means beyond. When we developed the supra computer, we meant beyond an ordinary computer. It is beyond an ordinary computer. If you go look up the supercomputer, well, you can go to Homeschooler today and you can learn all about this and read this book. And then you can go to supercomputer and learn all about it and how it is so much better than ordinary computers today. And it's very inexpensive, but what it can do. That's the modern world we live in, right? Things are getting more powerful, more valuable, and less expensive. And that is very, very true now in terms of what we can do with our math education today. So I believe that we are ready for the 21st century now. We have a program that demonstrates it. I'm hoping other companies and organizations come out with even better programs. That would be wonderful. And this is Craig Hain now, or my students call me Dr. Dell. And I'm going to leave you now with Chapter 10. And I hope that this has been valuable to you and that you will go on and figure out how to give your child a superior math education.